From Earth, Jupiter looks almost peaceful, a bright point in the night sky, larger than the other planets, glowing steadily from hundreds of millions of kilometers away. Through a telescope, it becomes more beautiful. Bands of white, orange, brown, and red wrapped around the planet like painted ribbons. At first glance, Jupiter looks like a giant marble floating in space, but that beauty is misleading. Jupiter is not calm. It is not solid like Earth, and it does not have a surface where a spacecraft could land safely. What we call the surface of Jupiter is really just the top layer of an atmosphere so deep and violent that it hides almost everything beneath it. For centuries, we could only look at the cloud tops and guess what was happening below. Then NASA sent Juno. Juno was not designed to simply take pretty pictures of Jupiter. It was sent to fly dangerously close, measure the planet's gravity, study its magnetic field, scan beneath the clouds with microwave instruments, and answer one of the biggest questions in planetary science. What is Jupiter really like underneath? What it found changed the way scientists understood the largest planet in the solar system. Jupiter is often called a gas giant, but that name can make it sound simple. It is mostly hydrogen and helium, like the sun, but it is not just a ball of gas floating quietly in space. It is a massive, rotating world with crushing pressure, extreme weather, intense radiation, and a magnetic field so powerful that it shapes the space around it. Its clouds are only the visible top of something much deeper. The colored bands we see from Earth are created by powerful winds moving in opposite directions. Bright zones and dark belts wrap around the planet, and inside them are storms, vortices, lightning, and clouds made of chemicals very different from Earth's weather. For a long time, scientists did not know how deep these cloud bands went. Were they just shallow weather patterns floating near the top of the atmosphere? Or were they connected to something much deeper inside the planet? Before Juno, Jupiter's interior was mostly hidden behind its own atmosphere. The planet was showing us a mask, and we had no way to see the face beneath it. Juno arrived at Jupiter in 2016, after a long journey from Earth. Instead of orbiting far away, it was placed on a path that takes it over Jupiter's poles and brings it extremely close to the cloud tops during each flyby. That kind of orbit was necessary because Jupiter is surrounded by deadly radiation belts. A spacecraft cannot simply drift comfortably around the planet forever. Juno has to drive in, collect data, and move back out again, surviving an environment that would destroy most electronics without protection. Each close pass is like a brief attack run through one of the harshest regions in the solar system. During those moments, Juno studies Jupiter in ways no spacecraft has done before. Its microwave radiometer looks below the cloud tops. Its gravity measurements reveal how mass is distributed inside the planet. Its magnetometer maps the shape of Jupiter's magnetic field. Juno is not just observing Jupiter, it is investigating a world that has spent billions of years hiding its secrets. One of the biggest surprises came from Jupiter's band and jet streams. From the outside, these colorful stripes look like weather. On Earth, weather happens in a relatively thin layer of atmosphere near the surface. So scientists wondered if Jupiter's bands were also shallow, moving only through the upper clouds. Juno showed that this was wrong. The planet's jet streams extend thousands of kilometers below the cloud tops. That means the strips we see on Jupiter are not just surface-level features. They are connected to deep flows of material moving far beneath the visible clouds. This was unexpected because it meant Jupiter's weather is not simply painted onto the top of the planet. It is rooted deep inside the atmosphere, involving a huge amount of mass. The colorful bands are the visible signs of something much larger happening below. In other words, Jupiter's clouds are not just clouds. They are the upper edges of a deep, moving system that reaches far into the planet. Then there is the Great Red Spot, Jupiter's most famous storm. It has been observed for centuries, a massive red oval large enough to swallow Earth. From far away, it looks almost like an eye staring out from the planet's atmosphere. Before Juno, scientists knew the storm was enormous across its width, but they did not know how deep it went. Was it a shallow storm drifting on top of the clouds? or did it reach far beneath them? Juno's data revealed that the Great Red Spot has roots extending hundreds of kilometers into Jupiter's atmosphere. That is far deeper than any storm system on Earth. It helps explain how the storm has survived for so long. A shallow storm might be torn apart more easily, but a storm with deep roots can remain tied to the planet's larger atmospheric motion. This made the Great Red Spot even stranger. It was not just a giant surface storm, it was a deep atmospheric structure, a rotating system connected to layers of Jupiter we cannot see with ordinary telescopes. And even now, scientists are still trying to understand why it has lasted so long, why it is shrinking, and what its future will be. Juno also gave scientists their first clear look at Jupiter's poles. Before the mission, most images of Jupiter focused on the equator and mid-latitudes. The poles were harder to study from Earth than from earlier spacecraft flybys. What Juno found there was shocking. Instead of one simple polar region, Jupiter's poles are surrounded by clusters of giant cyclones. These storms are arranged in strange patterns and appear to be surprisingly stable. They are not like Earth's hurricanes, which form, move, weaken, and disappear over days or weeks. These polar storms can last far longer and exist in an atmosphere with no solid surface beneath them. The poles made Jupiter feel even more alien. The familiar striped planet became something else entirely when seen from above. A world of swirling storms, geometric cyclone clusters, and atmospheric behavior unlike anything on Earth. It was a reminder that Jupiter is not just a larger version of our planet, it is a different kind of world. Juno also found that Jupiter's atmosphere is not mixed as evenly as scientists once expected. One important clue came from ammonia. Ammonia is one of the chemicals that help shape Jupiter's cloud layers, and scientists expected it to be distributed in a certain way. But Juno found patterns that were more complicated. In some places, ammonia seemed depleted. In others, especially near the equator, it extended much deeper. This suggested that Jupiter's atmosphere has hidden circulation patterns and strange weather processes that move material up and down in unexpected ways. Scientists have even proposed that Jupiter may have a kind of alien hail, mushy balls of ammonia and water that form during violent storms and fall deep into the atmosphere. This would help explain why ammonia appears missing from some upper layers. That idea sounds almost fictional, but it shows how strange Jupiter's weather really is. On Earth, we have rain, snow, and hail. On Jupiter, storms may be moving ammonia-rich slush through layers of atmosphere under pressures and temperatures far beyond anything humans experience. Juno was also sent to help answer one of the biggest questions about Jupiter. Does it have a core? Scientists once imagined Jupiter might have a compact solid core deep inside, surrounded by layers of hydrogen and helium, but Juno's gravity measurement complicated that picture. Instead of a simple, sharply defined core, the data suggested something more spread out and strange, often described as a diluted or fuzzy core. This matters because Jupiter is the largest planet in the solar system and may have formed early, shaping the movement of material around the young sun. Understanding Jupiter's core helps scientists understand how the entire solar system formed. If Jupiter's core is not neat and compact, it may mean the planet formed through a more complex process, or that its earthly history involved enormous impacts or mixing that blurred its interior. The deeper Juno looked, the less simple Jupiter became. NASA looked beneath Jupiter's clouds expecting answers, and it found a planet more complicated than anyone imagined. The bands were not shallow stripes, they were deep jet streams reaching thousands of kilometers below the clouds. The Great Red Spot was not just a surface storm, it had roots plunging hundreds of kilometers down. The poles were not calm, they were crowded with giant cyclones. The atmosphere was not evenly mixed, it held strange chemical patterns and possible ammonia-rich hail. The core was not the simple object many expected. Jupiter had been hiding all of this in plain sight. For centuries, we saw its clouds and thought they were the planet's face. But Juno revealed that the clouds are only the beginning. Beneath them is a deep, violent, layered world where weather becomes interior motion. Storms reach into darkness and the boundary between atmosphere and planet begins to blur. That is what makes Jupiter so fascinating. It is familiar enough to see from Earth, but alien enough to remind us how little we truly know. The largest planet in our solar system is not just a giant ball of gas. It is a world of hidden depths, and we have only just begun to look beneath the clouds.